Alright, Unit 5. It's been short but sweet, and there are 3 standards. Okay, there's 5A, which is about chemical versus physical changes. There's 5B, which is about balancing, I think. It's either balancing, yeah, it's balancing. Balancing, and then 5C, which is about exo versus endothermic reactions, alright? So, 5A, chemical versus physical. Okay, the main difference here is that, I'll type it, maybe it'll be faster. Chemical reactions require new chemicals to be made and old ones used up. So for example, if you take methane, which is CH4, and you react with oxygen, and you burn it incompletely, you get carbon monoxide and water. So here the methane is being used up, and it's creating H2O and carbon monoxide, and it's using oxygen. Whereas a physical change, no new chemicals, just a change in phase. So for example, if you go from water as a liquid and then you boil it, and it becomes a gas like this, that would be a physical change. Now, typically, the easiest way is just to look at the reaction. If you don't have the reaction available to you, chemical changes a lot of times have color, or gases are produced, like bubbles. There's heat changes, but that's true for physical as well. These are the big ones. So if the color changes, it's chemical. If new chemicals come out, it's a gas, like a gas. Or if it precipitates and it makes a solid that wasn't there before, then it's chemical. If there are no new chemicals, then it's just a change in phase. So if you just take something, you melt it, or you boil it, or you deposit it, or sublimate it, or any of those phase changes, that's a physical change. Okay, balancing reactions, I think you've gotten pretty good at this, but let's just think of one. So let's do a combustion one, because those are a little harder. So let's take acetylene, like an acetylene torch. We burn it, so it's going to make carbon dioxide and water. So what I want to do is first I just want to count. So I have, let's switch colors, make it easier to see. So I'm going to draw it here. C2H2 is CCHH. We circle it because it's all one thing. Oxygen's O2, we circle it, there's just one of them. COO is CO2, and water is HHO. So let's look at carbon first. Just save oxygen for last is my tip for you. So there's 2 carbons, 1 carbon. So I'm going to add another carbon dioxide. I have to add it all together, and I circle it. So there's 2 carbon dioxides right now. Now let's look at hydrogen. There's 2 and 2. So it's balanced. Let's look at oxygen. There's 2 and 4, 5, so I need to add another one here. But it's still not balanced, so I'm going to add another one. But now I have too many here, so I'm going to add another water here to balance that. Okay. But now I need another one here, right? There's 6 O's, 6 O's, that's all good. Just need to add another CCHH. Except now I need more carbon dioxide. Okay, so I've got 4 carbons, and now I have 10 oxygens, so I need more oxygens here. It's 10, so final check. 4 carbons, 4 carbons, 8 H's, no, 4 H's, 4 H's, 10 O's, 8 and 2, so that's 10 O's. So this is 2, 5, 4, 2. Okay, so there you go. You just go back and forth. Sometimes it takes a little while, like that one did. And then the last one was exothermic versus endothermic. Okay, so exo means you release heat. Endo means absorb heat. Okay, so it's very important that you keep in mind the chemicals are the ones releasing heat. So for example, if you dissolve something in water and it makes water hotter, the chemicals are making the water hotter. That would be exothermic because the chemicals are releasing energy into the water. Okay, so this would be water hotter when dissolved or reacted. All right, if something emits fire, okay, so burning is always going to be exothermic. It's always releasing energy. Endothermic, when you have things dissolved, is going to make water colder because it's absorbing energy, absorbs from water. Okay, and then otherwise, it's going to absorb energy. So sometimes it takes in fire. So if you think about like boiling water, if you boil water, you have to add fire. You have to put it on the stove or microwave or something. You have to put in energy, so it's endothermic. Okay, this one, you just kind of got to stop and you got to think about it. Is energy going in or out? And don't get confused about the water thing. That's what confuses people usually. It's the chemicals. Are the chemicals losing or gaining heat, not what's around them? Because if something's losing heat, something else is gaining heat. So you need to focus on what the chemicals are doing. Are they losing or gaining? You'll get it.